So, hi, my name is Marcin Możejko. Right now I am working as a developer in PwC. I'm developing deep learning solutions for our company's services. And in my speech, I'd like to say something about Keras, the newest version of Keras, Keras 1.0. And before I start, I'd like to ask some questions to you. So, whether anyone here have ever used Keras? Yeah, I've seen some. And how many of you are familiar with deep learning? Oh, it's great. Yes. So, in my speech, I want to say something about not only the newest version of Keras, but also about Keras at all, so the previous versions, and why I think Keras is great. So I will start with a little introduction, because I will mainly concentrate on deep learning solutions and neural networks, because Keras is even almost all about this. So I'd like to explain in a few words to anyone who doesn't know what neural network is. So what neural network is? So in fact, neural network is a function, mathematical function, which we are able to learn, and it has parameters which we can obtain from data in order to solve some task, whether is it classification task or is it regression task. So we have two types of parameters. We have parameters which are summably smoothly changing our network. So it's called usually weights. So right here, for example, you have weights. So this is a simple real numbers which are in some way parameterize our net. And we have different type of parameters. They are usually called hyperparameters, where you usually don't have this smooth dependency. And for example, this is the number of nodes here. So the usual computations are made in the following way. So we have some input. Right here you have an image. Then within every node some mathematical computations are performed. Usually it is dot product with weights of these inputs. And right now you have a new, so this is computed many times. And right now usually this is the input to the next layer, and finally you have an output, which is something, which is usually something you want to so it's usually some way connected with the problem which you want to solve. For example, here it's Sarah. So right now this function is simply telling you that given the image, it is giving you an answer that, okay, this is Sarah. So what is deep learning? So as you may see, this network has a property of which we may call the depth. Yeah, right now the depth here is, I don't know, around it's about 8. So these layers are connected with this depth, the number of layers. So usually, because there are loads of architectures in which the depth is defined in different manner, but here you may think about the depth as the number of layers which you have during your computations. And so deep learning is about neural networks which are deep. So what does it mean that neural network is deep? So it's hard to explain. Some people claim that 3 layers, that network with 3 layers is already deep, but there are nets which has, I don't know, thousands of layers. So it's hard to define what does it mean for net to be deep. But to explain where deep learning is really popular recently, I think that this image might help us, because you may think about these layers as a certain type of knowledge which you can get from the input. So in the beginning you are giving simply your input, an image, and then by these operations you may extract some features from this data, some knowledge, whether for example something occurred, or or whether you can see a certain pattern in your data. So for example, usually these nodes, for example, are coding such shapes, edges, shapes, dots, etc. And after, so deeper in the net, you can see the more sophisticated features like nose, eye, etc. So this is a part of faces. And in the end, you can see a different sorts, different of faces. So in my opinion, what makes deep learning so efficient and so popular recently is the ability to learn such knowledge and learn such feature in completely automatically. So you simply put a lot of input here, you put a lot of output there, and you are able within your computers to learn this network, simply to recognize these features and to solve this task. So this is what I mean by neural networks and deep learning. And so why do we talk about Keras? So Keras is a really simple framework for implementing neural networks. It's hard to define what does it mean simple. I consider it really, really simple, and I think that I will show you some examples, and I think that I will also convince you that it's relatively simple to start with Keras and start your own neural network research within I don't know, half an hour. So it is designed by François Chollet. I don't know whether I pronounced his surname correctly, but I had some doubts because that we may pronounce it in the way that in French means toilet, so I will stay within this pronunciation. And so François is right now a developer at Google, and so he developed Keras as an API for different frameworks, so for Tiano and for TensorFlow. So you may think about Keras as a framework which gives you simplified functions defined in those frameworks. I would like to say some words about Keras from different points of view. So I'd like to explain you why I consider Keras worth of interest. So I'd like to show you why I consider Keras as a great framework from the deep learning researchers' point of view, mathematicians' point of view, computer scientists' point of view, and common people point of view. So first, I think that Keras is great because of its simplicity. As for me, it's really, really simple to start with Keras. So here you can see a definition of a convolutional neural net, VGG-like neural network. So it may solve relatively not so easy tasks, and it could be defined within 10 lines of code. So here you have simply defining a model, which telling Python that you will be defining a neural net, and simply adding you are simply stacking layers one after another, and you will finally obtain a final neural network. So it's really easy to, I don't know, read carefully through documentation and to start implementing your own networks, I don't know, within an hour. So as for me, it was one of the main reasons why I was interested in Keras, because of this simplicity, and I was really amazed by how easy it is to implement a neural network in Keras. But I'm also a mathematician, and I think that right now, of course, usually deep learning solutions are really, really efficient, but it's really, as for me, as for a mathematician, it's really, really important to get knowledge what actually happens within neural network computations, and why are they so powerful. Sorry. And I think that another huge advantage of Keras is that it also gives you a lot of mathematical tools to get some knowledge from your neural net. So it's the main reason why you are able to do this is because of the fact that that Keras is built on Theano or TensorFlow, depending on which backend you will choose. So you're able to simply treat your neural network not only as a, I don't know, computational thing, but also a mathematical thing. And here you have a piece of code in which you are able to compute a gradient of output of your network with respect to your input. It is called a saliency maps, and it could give you a really interesting insights into what your neural networks is learning. So as for me, it was also really important to have an ability to do things like that. So another point of view is something which I called a computer scientist point of view. And you not only expect from a neural network to be understood or to be easy to maintain, but you also want it to do a computations really fast. And due to the fact that Keras is built on Theano, or TensorFlow again, you are able to do your computations in a really efficient way. It's because of the fact it's really interesting. So right here you can see a graph which shows you how Theano interprets your neural network. So Theano it's really interesting because of the fact that it treats your network as a whole. So it treats your network as a mathematical object which have inputs which are doing many computations, and it represents it as a graph, and it does a really amazing job in optimizing this graph to make your computations really efficient. So it also does a great job in, for example, makes your computation easy to be performed in parallel manner. So it's all you have that's all for free, because simply some guys from Theano did a great job. And recently, because I think that on May 10th, the latest version of Theano was released, and we know that for some tasks they are the best. So from this point of view, you can also trust your Keras solutions that because of Theano, your computations will be performed really well. Yes. And all of these features which I mentioned, they were all available for preview version of Keras. So right now we have something new and something which I consider really important and really revolutionary. So right now, you may heard a lot about how great deep learning is, but is it really compulsory to know linear algebra to start your deep learning research? So maybe it's hard to start your deep learning research simply because of the fact that it's pretty harsh. And I think that this new feature, which was introduced in Keras 1.0, is really amazing. And this feature is simply a wrapper which makes able to treat your Keras neural network as a scikit-learn classifier or regressor. So you can define your network within Keras and then simply do a lot of great job using loads of scikit-learn frameworks, packages, functions, etc. So I found this amazing because it really made my job easier. So for example, here this piece of code shows you that how it's easy to, for example, perform grid search for your hyperparameters, which is really, really important step in your development. So right now, you simply introduce your neural network as a family of Keras classifiers. So this function here, so I skipped the definition of it because it was pretty long, but it's not easy. It's not hard to implement it. So this is a function which simply takes up parameters and returns a compiled Keras model. If you want, I may show you it during the break. So then you're simply defining the parameter grid. So like here, number of layers, first layer size. So this is another parameter which I introduced. So which controls how the next, how many nodes has the next layer, knowing how many it had before, the dropout value, regularizers, etc. And simply performing grid search is really, really easy due to the fact that you are using scikit-learn function. And as for me, I found it even easier right now to start your deep learning research with Keras, and I think that it might make deep learning slide to the mainstream even more than before, because of the fact that you may start not only to implement your neural network easy within a half an hour, but you can spend the next half an hour simply optimizing it of course, for simple tasks. Optimizing it using scikit-learn functions. There is also another thing in the newest release which I considered really, really interesting. And this thing is more about the concept of neural network. So probably most of you heard about neural networks during some academic course, etc. And it's usually introduced by showing this graph, showing this activation function, showing how the computations are performed, etc. But a lot of deep learning researchers recently came across an idea that maybe it's not the best way to introduce the neural networks. And that's why right now they proposed a new definition, more modular definition. So when it comes to this definition, what the neural network is. So the neural network is a function which you are expecting to compute its value when given the inputs, and also propagate the error to its parameters when the error is known, and also, of course, propagate the errors to its input, simply to compute the all statistics needed for other parts of your network. And you simply then treat a neural network as a blend of different neural nets. And in my opinion, it's easier to think about neural net in this recursive way, because even in real life, when you are taking some kind of network and you will cut it into pieces, then you will get a set of different networks. And maybe it gives you another level of abstraction in thinking about your net. So here is another definition of the same network which I showed some slides ago. And right here, you may notice that there you had some kind of that you might divide this network into some parts. So it was first convolutional part, second convolutional part, and the last so-called dense part. And right now, Keras gives you opportunity not only to define your model simply by stacking one network after another, but right now it also gives you opportunity to simply treat every layer, and so different parts of your network as a functions. And right now it's like you may define, okay, so this convolution part, first convolution part, will be that I will take a convolutional layer, then I will simply treat it as an input to the next convolution layer, and then again I will treat it as an input to max pooling layer, and this will be a part of my network, which I will call convolution 1. The same might be done with the second part. Again, you can define in the similar manner this dense part, and then you can define your network as simply that you are first taking your input, you put it to convolution 1 part, and put the result of it to the convolution 2 part, and then finally apply the dense function to it. And as for me, it's much easier to think about neural network in this way. And there is also another advantage of such approach, that right now you not only have one model, which is easier to understand what's going on, but also you are keeping in your hand 3 models. And it's easier to analyze all these models on their own to get useful insights about what your network have really learned. So this is all what I wanted to talk about. So if you have any questions, I feel invited to ask me. And
I have one question. On the previous slide, you have a series of assignments. Can you explain how it works?
Yes.
It looks like the second one overrides the previous one.
Yes, but so these parts are relatively so. In fact, this code and this code is really similar, but it's different because of the fact that if you use this definition 2 times, you will construct a neural net in which those 2 parts will have exactly the same parameters. So if you want this from your network, it's absolutely good to use such design, because you...
There should be probably small capital. Yes, that's true. On the second line.
There's a type of convolution, but not this.
I didn't see.
Kind of recursive definition, right? But
The end of the line.
here I think it should be small.
Yes, of course. So, okay. Yes. So probably during the copy pasting the PowerPoint did some great job in correcting my mistakes and right. Yes, but if you treat, so for example, if you define this model one time and simply stack this one after another, then you can, for example, impose those two layers to have exactly the same parameters, and sometimes it's good to have such network, but in this case it wasn't crucial, and we wanted to simply to have different parameters. But it's interesting case.
Any questions?
Do you use Keras on production, or online application, real-time application, or just toy?
So right now we are using Keras for some business applications. So I cannot reveal more details about what we are doing, but we are using recurrent neural networks designed in Keras. And we are using Keras mainly because of the fact that we can treat this function as a mathematical object, because in business it's really important to get insights from your neural net. And that's why we choose Keras to get more info about your data, simply by using these tools which I mentioned before.
But are you using online, or you use prediction to some application? You use
Real-time or batch?
So no, we have a data set. So you mean what's the model, how this model is maintained? Yeah. So
no, how you use online output this model?
No, we have a huge table which we have to.
But it's online or batch?
So okay, you mean training phase? Yes. So it's.
I think evaluation time when you put some data and you have prediction, and some people can use this prediction on put new data and obtain some output.
So,
or does output is persist in the database?
no, so we simply train the model, then give this trained model to our client, and it simply gives a whole table to score everything what client wants. So it's not online, so it's rather batch. Yeah, so it takes place once a month. Yeah.
It was my question.
Yeah.
How about different architectures of neural networks, different than multi-layer perceptron? Because what we have seen on one of your first slides was a classical NLP, multi-layer perceptron architecture of neural network. How about different architectures like self-organizing map or some solutions like support vector machines, sometimes regarded as neural networks or sometimes not? This is the first question. And the second is, could you highlight any advantages of this particular implementation of neural networks compared to MATLAB implementations?
Mm-hmm.
Could you compare this?
So about this comparison, it will be hard for me because I haven't used MATLAB implementation of neural networks. I started from Theano, then I moved to Keras. So I don't know what's the differences, what are the similarities between them. But about different topologies, so in fact here is rather a convolutional topology, and this is also the kinds of topologies which are available in Keras are recurrent one, convolutional one, classic dense ones. The recurrent ones are in many different types. Like you have of course the most popular like LSTMs or GRUs. But what is about another architectures like this self-organizing maps, etc. I don't know. It's not in the documentation, so I think it's not implemented. But the good thing is that you can simply, if you know Theano, you can, and your neural net you are able to express your neural network as mathematical function using Theano and overloading this layer class. In Keras, you are able to implement almost all architectures which you want.
Can you tell us about documentation? Keras documentation is good or bad or? No, enough. It's very important for us.
Yeah, in my opinion, it's quite good, but it depends on what you are doing. If you are simply stacking, so if you simply use this in this way that you're simply taking your network and you are simply stacking one layer after another, it's really easy. But if you use some more sophisticated things, like for example tensor nets, or you want your neural net to be rather DAG than simply line, so stacked layers, there might be some problems. But I think that it's also useful, for example, to read the code on GitHub. And as for me, it's I solved almost every problem using documentations and reading code on GitHub, and it never took more than 2 days for me to solve any of this. But documentations, it's good, but it's not perfect.
Still perfect.
There are also some open source implementations of the deep learning. For example, I think the popular ones are H2O and Caffe, which is implemented at Berkeley. So have you had experience using that, and what's the comparison?
As I mentioned before, I used Theano and Keras for our implementations, but I read a lot, so I may in some way explain you what's the main difference between those frameworks. So there are a lot of frameworks which are based on Tiano, and this like, I don't know, blocks. I'm not 100% sure if PyBrain is built on that, but also, of course, Keras and Lasagne. It's built on Tiano. And what I found the most appealing for me in those frameworks is that mathematical stuff, these mathematical tools which Tiano gives you, because because there's another architectures like MXNet, like Caffe, like many others are built in different manner. So here you have So here the network is a whole. It's a graph, yeah, and you treat it as a whole. You are not so stacking one layer after another. Simply keeps your model as one object. And so in this way, when for example you are stacking these layers one after another in different frameworks, there might be some problems with this stacking, yeah, that, for example, with memory copying, etc. So it's mainly because of the fact that it's most of these, especially Python APIs for neural nets, were written in different manner than Tiano and Keras, etc. So they were built that some parts of code were moved to C++ and then stacked through Python. And here you have all moved to C++, and that's why I choose Tiano and Keras for our task. But I know that this is one of the main difference between those approaches.
Any more questions?
We can leave that for later during discussions during after party. One more question.
What are you looking in this intermediate data? Are you assuming that some layer does some particular task, and in output of this layer you got something concrete, or you don't know and experiment with that?
So within this intermediate layers output, I tried to check whether, for example, some interesting patterns or clusterization data were performed during the learning phase. So we found that really interesting patterns in data analyzing this intermediate layers output, and also I wanted to check because I also wanted to compare our different model using this approach, simply visualizing both cases within this intermediate layer, so we could get hint about what was learned in this model and what wasn't learned by this model but was learned by this preview one. So these were exactly the exact two reasons why we used this.
Okay, Marcin, you're going to be available during the after party?
Yeah.
Okay, so thank you so much for the talk. Yes.